All right, this is the similar figures review. So on the first slide here, there's just a little review of the three ways to show that two triangles are similar. Remember that similar figures mean that they're the same shape, just different sizes. And so sides are going to be proportional. That's what gives them the same, um, the scaling of the sides. And then the angles are congruent. So that means they have the same shape. So angle-angle similarity here. If you can show that two pairs of angles are congruent, then we know the triangles are similar. They have to be the same shape. Right, side, 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 we'd have to show that the corresponding sides, the ratios of the corresponding sides are all equal. And that would show that those sides are all proportional. Or we can find that the ratios of two pairs of corresponding sides are equal, as long as their included angles are also equal. And that would give us side, angle, side. Okay, the first question here just asks for the scale factor. So the distance between A and B is going to be 3 units, and the distance between A prime and B prime is 2 units. Okay, so when we're thinking about this, our scale factor can be either be 3 over 2 or 2 over 3. But we're going from the black one to the orange one. So we're going from the bigger one to the smaller one. So we're getting smaller. So we want to use 2/3. The orange one is 2/3 the size of the black one. Okay, so our scale factor here would be 2 over 3. Okay, round to the nearest hundredths place. So that's 2 decimals. So let's do 0.67. And that's going to give us our right answer. Right. Got scared there for a second, but I didn't read the directions. Right, round to the nearest hundredths place. Right, scale factor here. So let me pull up my annotations here. If you're going from, you can pick any of these, A to D. So to get from A to D, we have to go up 4 and right 2. Okay, to get from A prime to D prime, we have to go up 2 and right 1. Okay, so we could find the distance from A to D and A prime to D prime using the distance formula or the Pythagorean theorem. But we can see here that we have to go twice as far, or half the distance, right? Instead of going up 4, we're only going up 2. And instead of going right 2, we're going right 1. So we're going half the distance, so our scale factor is going to be 1/2. Okay, probably written as 0.5. Nope, or they accepted 1 over 2. Okay, 0.5. Okay, determine if the triangles are similar by side, side, side similarity. So we need to check and see if the ratios of the corresponding sides are equal. So in order to determine which sides correspond with which sides, if they're similar, the smallest side is going to correspond with the smallest side, and the largest side is going to correspond with the largest side on the other triangle. So if I notice AC here, 12 is or 10 is the smallest number, and then DF 12 is the smallest number. So if these are going to be similar, 10 is going to have to match up with 12. Okay, then 12 is in the middle, 14.4 is in the middle. So 12 is going to have to match up with 14.4. And then 15 is going to have to match up with 18. Okay, if we reduce these 10 over 12, that's going to give us 5 over 6. 12 divided by 14.4 is going to give us 5 over 6 as well. And then 15 divided by 8 is also going to give us 5 over 6. You can divide by 2 and 2, 2 over 2, or 1/2 and 1/2. Divide the top and the bottom both by 2. Here you can divide the top and the bottom both by 3. And then here, we can just double check. All right, 12 divided by 14.4 gives us 5 over 6. Right, 5 over 6. So 2.4 would be your, you divide both sides by 2.4. So 12 divided by 2.4 is 5. And then 14.4 divided by 2.4 is 6. Okay, so that one's a yes. Side, side, side. The ratio of all three corresponding sides are equal. Okay. Are the triangles similar here? So we have they're giving us information about two pairs of sides. So DE is 2, so DE would match up with JH, so 2 over 1. And then 5.8 matches up with 2.9. So that's one goes into 2 twice. 2.9 goes into 5.8 twice. So we have two ratios of corresponding sides are equal. And the included angles are equal as well. Angle D is 70 degrees, so that's congruent to angle H. So we have two pair of sides, two corresponding sides. The ratio of two corresponding sides are equal, and their included angles are equal. So that's going to be side, angle, side. This one's yes. Side, angle, side. Okay. The next one here. So here we have one pair of angles congruent and one pair of sides that are congruent, but they don't give us any other information. And so again, our three ways are angle, angle, side, 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 or side, angle, side. Since we don't have any more information, we're going to have to say no. I mean, they could be similar, really, but we don't have enough information. Don't have enough information. All right, next one, are the triangles similar? So again, if they're similar, the biggest side is going to match up with the biggest side and the smallest with the smallest. So here's the biggest and the biggest. So we would do 30 over 15. Then you have 26 over 13 and 26 over 13. Those are going to all equal 2. So we get 2 equals 2 equals 2. So we have the ratio of three pairs of corresponding sides are all equal. Therefore, these triangles are similar by side, 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 side similarity. The ratios of all three pairs of corresponding sides are equal. The ratios are equal. That means the sides are proportional. Proportional. Right? If the ratios are equal, then they're proportional. Right, are the triangles similar here? So we have one pair of angles that are congruent in the middle there. And then one pair of sides. So we're going to have to say not enough information here, not enough. We only had one pair of corresponding sides. That would have been, you can't even have a proportion there if you only have one ratio. To have a proportion, you have to at least have two ratios. All right, the next one here, we can check again. So 28, largest side would match up with largest side. So 28 over 14. And then 10 over 5. So 28 matches with 14, 10 matches with 5. That's going to be 2 equals 2. So those ratios are equal. So we have two pairs of sides where the ratios of those pairs of sides are equal. And then we have angle V is congruent to angle X. That's the right angle theorem. We know all right angles have a measure of 90 degrees. So by the right angle theorem, angle V is congruent to angle X. And since we have two pairs of sides that are proportional, and the included angle, the angle between those sides is congruent, we can use side, angle, side. So yes, these are similar. By side, angle, side. Determine if the triangles are similar by angle, angle similarity. So we have angle A is congruent to angle D. Okay, but we can also add vertical angles in there as well. Angle BCA is congruent to angle ECD. So we can say yes. Right angle theorem gives us angle A is congruent to angle D. And then vertical angle theorem tells us angle BCA is congruent to angle ECD. And that gives us two pairs of congruent angles between the triangles. So they have to be similar. Because remember, if two pairs of angles are congruent, the third pair of angles would also have to be congruent because the three angles of a triangle are going to add up to 180. So that's the third angle theorem. That third pair of angles is also going to have to be equal. All right, so again, we're just matching up here. Here's the two arcs, so that matches with this angle here. Those angles match up on the right. So that means X matches with 14, and 3 is going to match with 21. Make sure you're matching them up from the same triangle, right? So if X is in the numerator and you're picking 14 from the other triangle, you got to start again with the first triangle. This is what I want right here. Okay, and then we can cross multiply. So we get 21x equals 42. We divide by 21. We get x equals 2. So 2 over 3 is going to equal 14 over 21. All right, next one. Okay. We got angle, angle similarity. So the two triangles are congruent by angle, angle similarity. They have two pair of angles that are congruent. All right, first thing though, we have x and 28, and we have 4 feet 6 inches and 8. So we need to convert our 4 feet 6 inches into just feet. So there are 12 inches in a foot, 12 inches in 1 foot. So 6 inches is going to be equal to 0.5 feet. Okay, so this we really want to use 4.5 feet, right? It's 4 feet and 6 inches. So 4 feet and 0.5 feet because 6 inches is half a foot. So 4.5 feet. Okay, and then we can set up our proportions. So x is the height. It's going to match up with the height of the person, which is going to be 4.5. Okay, if you started with the left triangle, we got to start with the left triangle again. So that's going to be 28 over 8. We can then cross multiply. So we get 8x. Let's see, that would be 56, 112, 126. Yep. So that's going to be 8x equals 126. And then we can divide both sides by 8. This is going to give us 15.75. We got to see what we got to put in as the answer. 15.75. Yep. Okay. Next one here, a 10-foot vertical post casts a 20-foot shadow. So here's our vertical post. The post going up and down is 10 feet high. Okay, it casts a 20-inch shadow. Okay, let's redraw this. So 20 inches, first of all, we got to be in feet, or at least we got to get the same unit here. So let's convert 20 inches into feet. So 20 inches, right there are, again, 12 inches in a foot. We put 12 inches at the bottom because we want the units to cancel out. So we get 20 over 12 feet. So 20 divided by 12, that's going to be 1.67. So let's just leave it as a fraction. Well, we can do 1.67. I'm just going to put a bunch of well, I'm going to leave it, let's leave it as a fraction. So 20 over 12, right, which is going to equal, let's see, we can plug in 4. 4 we can divide by 4, divide by 4. That's going to get 5 over 3. Okay, so 5 over 3 feet. Okay, so you have a 10-foot post. You have a 5/3 foot shadow. Again, that's 1.67 or 1.666667. Okay, but we're going to leave it as 5 over 3 feet. Okay, and then you have a much bigger cell phone tower that's 120 feet tall. Oh no, we're looking for the height. That casts a 120-foot shadow. Okay, so our shadow here is 120 feet. And we are looking for the height of that tower. So the angle the sun's coming down is going to be the same because they're nearby each other. And then the tower and the post are both vertical to the ground. So they're both right angles. So we have angle similarity, which means the sides are proportional because similar figures have congruent angles. Angles are equal and sides are proportional. So we set up our proportion. 10 is going to match up with x. And then 5/3 is going to match up with 120. We cross multiply, that's going to be 1,200 equals 5 over 3 times x. Okay, we can multiply both sides by 3. That's going to give you 3,600 equals 5x. And then we can divide by 5 on both sides. And we get x equals, it goes 5 goes into 500 100 times, right? So 720 feet. Looks like it's good. 720 feet. Yep. So the height of that tower is 720 feet. Right. So here, again, we want to match up hypotenuse with hypotenuse. So we're going to do 39. Going to match up with x plus 6 equals, if you started with the first triangle, the left triangle, you got to start with the left triangle again. So 2x minus 4 matches up with 24. Okay, we can cross multiply. So 39 times 24 is 936. Cross multiply 936. Then we have x plus 6, 2x minus 4 multiplied by each other. So that's going to give us, if we distribute here, FOIL out, we get 2x squared minus 4x plus 12x minus 24. Okay, I'm going to divide, I notice everything here is an even number, so I'm going to divide by 2. So 936 divided by 2 is going to give me 468. That's going to be x squared. This becomes 8x. Maybe we should just not do that yet. So minus 2x plus 6x minus 12. Okay, combine like terms. So we get 468 equals x squared plus 4x minus, so that was a 6. That's pretty sloppy there. Half of 12 was 6x. Okay, minus 12. Okay, we want to subtract 468 because we're going to want to factor this. And so we're going to, we're going to want to find the zero. So we got to set this equal to 0. So minus 468 from both sides. And we get 0 equals x squared plus 4x minus 480. Okay, so we got to use the x method now to factor. We need something that's going to multiply to negative 480 and add to positive 4. So there's going to have to be a gap in the two numbers there. So we can start trying different things. So how about 18 times 22? Nope, it's got to be higher. How about 20? Well, we can try 19 times 23. That's not high enough either. 20 times 24. Oh, and that looks pretty good. So we just got to figure out the sign. So we want negative 480. So one needs to be positive, one needs to be negative, and then we want positive 4x. So that means we have to do positive 24 and negative 20. So this is going to factor into x. I can move this up here though. So we got 0 equals x minus 24, and then x plus 20. Right? I'm sorry, plus 24x and then minus 20. The positive 4x. Okay. Then we can set those each equal to 0, right? In order for this to equal 0, either the first term or the second term has to equal 0. So we can do x plus 24 equals 0, and then x minus 20 equals 0. If we subtract 24 from both sides, we're going to get x equals negative 24. If we add 20 to both sides in the other one, we're going to get x equals 20. X is a distance, it's a length here, so it can't be negative. So we're going to have to go with x equals 20. Unless we've done something wrong. There we go. All right. So we have to find the measure of angle D. We have to find the distance between E and F and the distance between D and E. So the angles are the easy ones. Angles are congruent. So we know that angle F here, right? So angle B is going to match up with angle D. I'm sorry, angle B is going to match up with angle F, so that one's 100. Angle C is going to match up with angle E, so that one's 20. Right? If the figures are similar, which is what it's saying right here, triangle ABC is similar to triangle DFE. If they're similar, we know angles are congruent and sides are proportional. Right? We know the three angles of a triangle add up to 180, so we can do 180 minus 100 minus 20. And that's going to give us 60. Okay, so we know the measure of angle D is 60, and we know the measure of angle A is 60. Okay, so the measure of angle D is 60. All right, the sides, we can set up a proportion for the sides because we know the triangles are similar. So 3 matches with 2. I'm going to put an X here and a Y here. 9 is going to match up with X. And then 11 is going to match up with Y. So my first proportion that I'm going to solve is going to be 3 over 2 equals 9 over X. I'm going to cross multiply. I'm going to get 3x equals 18. And so I'm going to get x equals 6. Divide by 3, divide by 3. And x was EF. So I'm going to put in 6 here. And we're good. Okay, and then I'm going to do 3 over 2 equals 11 over y. Right, so 3 over 2 and 11 over y. I'm going to cross multiply. That's going to be 3y equals 22. Then I'm going to divide both sides by 3, and I'm going to get y equals 22 over 3. Okay, and it looks like they want us to round, so 22 over 3 isn't going to work. So we need to put that in, and that's going to be 7.33. 7.33. Okay. And then the last one here, again, angles are congruent. So B is going to match up with E. Okay, A and D match up, so A is 50 as well. The three angles of the triangle add up to 180, so we can do 180 minus 50 minus 70. That's going to give us 60. Right, so C and Z would both be 60 degrees. Okay, and if they are similar, the sides are going to be proportional. So we can say 5 is going to match up with 10, 6 with Y, and then X with 4. So we're going to do 5 over 10 equals X over 4. Cross multiply, you get 10X equals 20. Divide by 10, you get X equals 2. Okay, and then we'll do 5 over 10 equals 6 over Y. Cross multiply, we're going to get 5Y equals 60. You divide by 5 on both sides, and you get Y equals 12. Okay, and that's it for the similar figures review.